Okay, this is day 15 of Unit 4. We started today with this warm-up. So pause the video, try it, and then play to check your answers. So it says, when finding x-intercepts, what does it mean if you get complex numbers for x? Remember, our goal is to find the x-intercept. So if we're getting complex numbers, that means there are no x-intercepts. Okay, if I graph that parabola on the real coordinate plane, it would not be intersecting with the x-axis, so it doesn't have any x-intercepts on the real coordinate plane. On the other hand, when I'm solving a system of equations and I get complex numbers for x and y, what does that tell me about the graph of the system? Well, that tells me that on the real coordinate plane, the two graphs do not intersect. So if we're talking about like a parabola and a line, something like that, they're never going to intersect. That's what the graphs would look like if I graph the system of equations. Graph those equations, I'd see two graphs that don't intersect on the real coordinate plane. Now, realize we still have solutions. We still have x and y values that are complex numbers, but graphically speaking, on the real coordinate plane, we would not see those graphs intersect. So the graphs do not intersect. Okay, just make sure you don't get the two of these questions confused. If the goal is to find the x-intercepts and you get complex numbers, then there are no x-intercepts. That has nothing to do with intersection of two graphs. And vice versa, if the goal is to solve a system of equations, that means our goal is to figure out where the graphs intersect. They don't intersect, so they don't have real numbers as their solution. This here has nothing to do with x-intercepts. So if my goal is to solve a system of equations and I get complex numbers, I would not say that the graph doesn't have any x-intercepts. That again has nothing to do with x-intercepts. My goal wasn't to find the x-intercepts. My goal was to find where the graphs intersect, in which case they don't if the solutions are complex. Okay, so then we worked on a couple example problems, and that should be, if you weren't in class, I've attached that handout to the Schoology page, so you can print that out. We did example number 1 together in class, so that's what we're going to do right now. So we're talking about a catapult. Catapult launches fireballs over a castle wall at an enemy. So I'm immediately going to draw a picture here. So I have this catapult, and hopefully you know what that means, like a something like that, which is shooting fireballs. Now realize if it's pulling back here, it's going to shoot or release the fireball when it's straight up and down. Okay, so right about there is where the fireball is going to be released, and then it's going to go up for a bit. It's going to reach a maximum, and then it's going to come down, and eventually it'll hit the ground. Okay, so we can see then directly down, touching where the base of the catapult touches the ground, that is going to be our 0, 0. Okay, now we have this equation that we were given in the problem for the path of the fireball, and it says it can be modeled by a parabola, quadratic equation, which we can see here. So realize this is the part of the path that is relevant to the problem, the part that I drew, but this is actually a full parabola. So I'm going to extend this and just continue the parabola to the other side, even though what's over here on the left of the catapult really isn't relevant. We don't really care about going back behind the catapult because it's not released until right here. Okay, but now I have the full parabola drawn. So we have our equation, which we were given, and in part A, it says, what is the height of the fireball just as it is released? Well, we talked about the fact that just as it's released is right here. So I know that I'm trying to figure out the values of the point that's right there. And I'm also told h is the height of the fireball in feet, and x is the horizontal distance in feet from the point it is released. So if x is the distance from the point it's released, and I'm trying to figure out the values at this point, well, if this is where it's released, then it's going to be 0 feet away from where it's released, because that is where it's released. And that's the x value because it says the horizontal distance away from the point it's released is x. So we know 0, comma, we don't know the y value. So if you're paying close attention to how we define the variables and this picture, we realize that we're supposed to substitute 0 in for x into the equation and solve for y, or in this case, y is represented with the letter h. So let's do that. This is part A. I'm putting 0 in for x, and I'm solving for y. So when I do that, I'm getting 200, and these are represented by feet. So 200 feet is the height of the fireball when it is released. So I'm going to go ahead and put 200 in my picture there. So that takes care of part A. So part B says, what is the highest wall the fireball can clear? Okay, so if I'm looking at my picture, I can see the highest wall that we can clear. It's going to be located at the vertex because the vertex is the highest point of this parabola. So I'm going to go ahead and draw in that wall. And I know that to figure this problem out, I'm going to have to figure out the coordinates of the vertex. So that's what I'm about to do. This problem is kind of similar to the rabbits that we did yesterday, just clearing the fence. So I'm going to take my equation, which is currently in standard form, and I'm going to get it into vertex form. Well, we know to get an equation that's in standard form into vertex form, we're going to have to complete the square. I'm seeing these decimals, and I know that you're better with we're better with fractions when we're completing the square. So let's have the calculator change negative 0.00125 into a fraction, or if you know that 0.125 is 1/8, then you'll probably be able to figure out without a calculator that 0.00125 is going to be 1/800th, and this is a negative. So negative 1/800th. If you want the calculator to do that for you, just type in 0.00125 and then math frac, and it'll change it into a fraction. So anyway, we have negative 1/800th x squared plus 0.5 we know is 1/2 x plus 200. And we want to put that into vertex form. So we're going to bring out the negative 1/800th, factor that out. We're left with x squared. We're left with positive 200. And now we're going to figure out what negative 1/800th has to be multiplied by to give us 1/2. So we're doing 1/2 divided by negative 1/800th, which is going to be negative 800 times 1/2. Which is negative 400. And you may use a calculator since these numbers are big. You may use a calculator to help you. So negative 400x. So I'm dividing negative 400 in half, which is negative 200. I'm squaring negative 200, which gives me 40,000. And 40,000 is what I'm adding. So now that I've added 40,000, I have to figure out what randomly got added. Remember, that comes from 40,000 times negative 1/800th, or 40,000 divided by negative 800. And that is negative 50. So negative 50 was randomly added on, which means I need to add positive 50 onto the end to balance the equation. So now I have h equals negative 1/800th. I have the quantity of x minus, we had 200 squared. And 200 plus 250 is 250. So there's our equation in vertex form, which means our vertex is 200, 250. So I'm about ready to answer the question, but I didn't answer it yet. So let's go back to what the question was. It said, what is the highest wall the fireball can clear? Highest wall, meaning we're looking for the height. We'll go back to your definition of variables. The height is the y, or the h. So we're going to use the 250 from the vertex. And by the way, in my picture, I'm going to go ahead and label 200, 250. But the answer to part B is 250 feet because that's the height of the highest wall. That's the height of the vertex. So that takes care of B. C asks, how far from the catapult does the fireball reach its greatest height? So we know its greatest height is here, which is 250 feet high. How far away from the catapult? Well, that would be the distance from the catapult to the vertex, which means 200, because that 200 is the horizontal distance between the catapult and the vertex. So I don't have to do any work for that one. I already did the work when I found the vertex. 200 feet is the answer for part C. Part D, how high is the fireball when it is 50 feet in front of the highest wall from part B? Well, let's go back to our picture. So here's our picture, here's our highest wall. If we're talking about 50 feet in front of the highest wall, in front would be over here somewhere. So we're talking about right there. So if I know that this distance away is 200, and I'm going 50 in front of that, that means I'm subtracting 50 from 200, and that takes me to 150 for my x. I don't know the y, which is what I'm about to figure out. So I'm going to substitute 150 into the equation for x, and I'm going to solve for y. Now, we can either, this is part D, we can either substitute the 150 in for x into vertex form or standard form. It doesn't really matter. I think I'm going to put it in vertex form. So h I don't know, but I do know that the x value is 150. So I'm going to substitute 150 in for x. And when I do that, I'm getting negative 1/800 times negative 50 squared plus 250. When I square negative 50, I'm getting 2500 plus 250. Now I'm going to need help from my calculator. Negative 1/800 times 2500 gives me negative 3.125 as a decimal, plus the 250, which is going to give me 246.875, and these are feet. And that's my height when the distance is 150 feet away. So 246.875. Okay, that's part D. Moving on to part E. So part E, what is the maximum distance it can be launched? So I'm going to go back to my picture here. So maximum distance it can be launched, remember maximum distance meaning in this direction to the right. Okay, and I can see that the furthest point of this path is right there. Okay, so that point is what we're trying to figure out the coordinates for. Now, if that's the maximum distance it can be launched, then remember the distance is the x. So that's what we don't know is the distance. But what we do know is this is touching the ground. So if it's touching the ground, then how high is it off of the ground? It's 0 off of the ground, meaning we know the height, or in other words, we know the y value. So if I know the y value, I'm going to plug 0 in for y, or h, and I'm going to solve for x. So I'm going to take my equation. Now again, I could either use standard form or vertex form. Looks to me to be easier if I use vertex form to solve that. So I'm going to go ahead and put 0 in for h in vertex form. So I have x minus 200, the quantity squared, plus 250. Okay, so I'm going to go ahead and use square roots technique here and bring the 250 over. Next, I'm going to divide by negative 1/800, or that's the same thing as multiplying by negative 800. And when I do that, I'm getting 200,000 is equal to x minus 200, the quantity squared. Now I have it in the format that I can take the square root of each side. Try and separate these problems a little bit here. There we go. So I can take the square root of each side. I'm getting the absolute value of x minus 200 is equal to the square root of 200,000, which I'll get a decimal approximation here. So because I'm getting a decimal approximation, I'm going to change my equals to an approximate, approximately 447.21. So now I'm ready to make that plus or minus and take away my absolute value. Next, I'm going to add, there we go. I'm going to add 200 to both sides. So x is approximately 200 plus or minus 447. I don't know why that keeps shutting off, 447.21. So when I figure out what they both equal, I'm getting 647.21 or negative 247.21. So now we have to go back and answer the question. So we want the farthest distance from the catapult. Well, the farthest distance would be the one that's on the right because the negative one is to the left of the catapult, which we don't care about that. Remember, it's not actually being released backwards. So we want this one here, which would be the positive 647.21. So my answer for part E is approximately 647.21 feet. Okay, which is our answer. And that takes care of part E. So we're going to move on to part F. What is the farthest distance the catapult can be set up from a 230-foot wall and clear it? So now think about that, and I asked students in class to think a second. So what are they giving us here? Look back to the definition of the variables. X is the distance in feet from the point it's released, and h is the height. So when they give us 230-foot wall, are they giving us the h, or are they giving us the x? The answer is they're giving us the h, the height. So that's exactly what we're going to do. We're going to substitute, this is part F, we're going to substitute 230 in for h, which is the y, and we're going to solve for x. So again, I'm going to use vertex form. And I'm going to go ahead and solve this for x. So I'm going to subtract 250, which gives me negative 20 on the left. Whoops, I already subtracted the 250 there. So then I'm going to divide by negative 1/800th or multiply by negative 800, which gives me 16,000. And next I'm going to take the square root of each side. I'm going to end up with the absolute value of x minus 200 is equal to, again, we'll have a decimal approximation here, so I'll change that to approximately 126.49. So then I'm going to get rid of the absolute value by making 126.49 plus or minus. And then I'm going to add 200. So 200 plus or minus 126.49 is going to give me my approximate values for x. When I do that, I'm getting 326.49 or 73.51. Okay, so now we need to think here about the question. The question, what is the farthest distance from the catapult, or the catapult can be set up from a 230-foot wall and clear it? So I'm getting 73 or 326. Let's remember what that means. I'm going back up to my picture. So, whoops. So what I'm looking at here is I have this 230-foot wall, which is going to be just a little bit to the left of the highest wall, right? So the question is, what's the farthest distance if that's the wall is at 230 feet high? So the farthest distance would be the one that's the bigger number, right? Because we have those two numbers and we have one that's going to be so far away, and we have the other one that's going to be even further away. So we want the number that's bigger. That would be the furthest distance away from 0. So we want the 326.49 feet. That is the one that's the farthest away from that 230-foot wall. Okay, and lastly, we are supposed to answer how high in the air is the fireball at a distance of 230 feet from the catapult. So again, think to yourself, when they're giving us this distance of 230 feet, are they giving us the x or are they giving us the y? In this case, because they're talking about the distance away from the catapult, they're giving us the x. So I'm going to use the equation. We can either use vertex or standard form. This time I think I'll use standard form. But again, either would work, and I'm substituting 230 in for x. So when I do that, I'm getting negative 1/800 times 52900, or 52,900 is 230 squared. Plus 115 is half of 230 plus 200. So when I simplify that further, I'm getting, I'll change this to approximate, 66.125. Actually, that's not approximate, that's exact. That's negative, plus 115, plus 200, which is equal to 248.875 feet. That's the height. So that's my answer. That is the height. That's how high in the air the fireball is when it's 230 feet from the catapult. Okay, so that takes care of our first example, example 1. Now we, next thing we did in class was we moved on to the next page and we took a look at example number 2. So this time we have this bakery that sells loaves of bread, and it sells more when they reduce their price, but then its profits change. So the function we were given in the problem is h is equal to negative 100 x squared plus 350x minus 25 fourths. That's the equation. And it says that models the bakery's profits in dollars. So when I read that in class, I stopped and said, okay, well, what do you think that means? That means that H represents the profit. Okay, so basically they're defining H as the profit. And remember, H is like your Y. Okay, so then X, it actually says, where X is the price of a loaf of bread in dollars. So profit in dollars is our Y. X is our price per loaf. And again, that's in dollars. Okay, so that'll help us decide what we're given and what we need to find. So A, find the daily profit for selling the bread at $2 per loaf. So are they giving us the X or are they giving us the Y when they're giving us $2 per loaf? So think about that. Hopefully you said that they're giving us the X. So that tells me in part A that I'm going to substitute 2 into this equation everywhere I see an X. So H is going to be equal to negative 100 times 2 squared plus 350 times 2 minus 25 fourths. So let me simplify that. I'm getting negative 200. Whoops, sorry, that's 2 squared, so that's negative 400. Because we squared 2 and got 4, 4 times negative 100, negative 4 hundredths. there we go, fix that. 350 times 2 is 700 minus 25 fourths. So we have 700 minus 400, which is 300. 300, and then minus 25 fourths is minus 6.25. So that gives us 293.75. And remember what that's representing. That's the profit. So those would be dollars. $293.75 is the answer for part A. Okay, next, part B. So what price should the bakery charge to maximize its profit? Well, I'm visualizing this equation, which starts off negative 100x squared. So we know that that means it's an upside down parabola. So we also know that the y is the profit. So if I'm looking to maximize the profit, that means I'm looking to find the maximum y, which means I'm looking to find the highest point. So I'm looking to find the vertex. So if I have this equation, which is in standard form, I'm going to want to get it into vertex form so I can figure out the vertex. Specifically, I'm going to get it in vertex form by completing the square. So let's go ahead and do that. We're factoring out the negative 100. So when I factor that out, I'm left with an x squared. And then I have to figure out what I'm multiplying negative 100 by to get positive 350. So you realize that's negative 3.5, or as a fraction, negative 7 halves x. So now I'm taking negative 7 halves and dividing it in half, which is times 1/2, which is negative 7 fourths. And I'm squaring negative 7 fourths. And I'm getting positive 49 sixteenths, which is what I'm adding. And it's actually 49 sixteenths times negative 100, though. So I'm going to simplify on the diagonal before I multiply. So 4 goes into both 16 and negative 100, so that gives me 4 and negative 25. So negative 25 times 49 and 4 times 1. You can use a calculator to help you. So 49 times negative 25 gives you negative 1225. And 4 times 1 is 4. So what was just randomly added was negative 1225 fourths, which means I'm going to add positive 1225 fourths on the end. So now I have h is equal to negative 100 in the front. I have a quantity squared. Remember, I go back to what I had before I squared, so that's x minus 7 fourths. And that's squared. And then 1225 fourths minus 25 fourths is 1200 fourths. And we'll simplify that in the next step. So we're getting negative 100 times, I'm going to think of this because I want to think of money here. I'm going to think of the fraction now as a decimal. So I know that 7 fourths is 1.75. And I know that 1200 divided by 4 is 300. So now I can see that the vertex is 1.75 comma 300. So now I'm going to go back to the question that was asked. What price should the bakery charge to maximize its profit? Well, remember, the price is x. So here is the vertex, 1.75 300. We care about the x part of the vertex. So the price that they should charge is $1.75. Okay, so that's the answer for part B. Part C says, what is the maximum profit? Well, we just figured that out when we found the vertex. It's the y part of the vertex. So the maximum profit, and I know that because y is the profit. So the maximum profit is going to be $300. Okay. So that takes care of our example problems for today. Your homework for tonight is to complete the next two problems in the packet. They're marked practice problem 1 and 2 on the next 2 pages. So you want to complete those practice problems 1 and 2 for homework for tomorrow. Also, I want to point out that practice problem number 2, talking about the Verrazano-Narrows Bridge, just to point out, there was supposed to be a picture there. It is going to be a parabola that's right side up. Okay, so just want to point that out. You want to use a parabola that's right side up. And these right here are going to be 650 feet up above the center of the roadbed. So the center of the roadbed's here, and then we have 650 feet up is the height. Okay, I just wanted to point that out since there was no picture provided. Okay, so get problems 1 and 2 done for tomorrow. Team test coming up later this week on Thursday, and then you have an individual test next week on Monday and Tuesday.